This is inertia 2. Remember, inertia is the tendency that something has to keep doing what it's doing, or in other words, pretty much synonymous with mass. Okay, so kind of like the questions that we were doing on inertia 1, except for these first, number 1 here, these first 4 parts. This is a position versus time graph. This is the position of something, not its velocity. So we've seen position versus time and velocity versus time graphs. So we need to be careful about the conclusions that we make here. So during what time intervals is the unbalanced force on the object equal to 0 newtons? So unbalanced force is where the velocity is constant or the velocity is 0. Here, how do we get velocity from a position time graph? Velocity is the slope of position versus time. Oh dear, that's a mistake there. See there where that says position meters per second? That should just say meters. Sorry about that. So I was just going to say the slope of this, meters over seconds. And the one that we were doing last, where did it go? Right here. This one, the slope of velocity versus time is meters per second over seconds. Meters per second, that's acceleration. So slope of velocity versus time is acceleration. Slope of position versus time is velocity. We know that. We've known that for quite some time now. Okay, so if we want the velocity to be constant or 0, so if the velocity is the slope of this, does this have any places where the slope is 0? Yes. I would say from, looks to me like about from 0 to 7.5. So during what time intervals? 0 to 7.5. And other places where the velocity, or in other words, slope of this is 0, I'd say from 35 to, well, let's just say that goes to 45. 35 to 45. But then also, if the slope is constant, in other words, if this is a straight line, that would also be a place where the velocity is constant and therefore the forces are balanced, or the unbalanced force is 0. So looking at this here, it does look like there's a little stretch in the middle here where this flattens out and is straight. So I'm going to say, like, you can do your best to say what you think where it is. I'm going to go from maybe here, 17.5, to maybe here, 22.5. It looks like it starts to bend, and then it's just not for very long, but there is a little stretch here in the middle where it's flat. And if the slope is 0, that means if the slope is constant, rather, that's velocity is constant for that little stretch. So I'm going to call that from 17.5 to 22.5. It's not long in the graph, but that's a good 5 seconds worth of constant velocity. How do you know? Because, for this reason, because the velocity is constant or v equals 0, right? It's constant here and 0 here. During what time intervals is the unbalanced force not equal to 0? So that would be from 7.5, all the other places, right? 7.5 to 17.5, and from 17.5 to 35. How do we know? Because the velocity, which is the slope of our position versus time, is changing. The slope of this is changing. This is bending, which means the slope is changing. During what time intervals is the unbalanced force negative? Okay, so the unbalanced force is negative if the slopes are decreasing. So here I have this positive slope, and those slopes are going back towards 0, right? Here, I'm going from having a slope of 0 to positive slopes. If we want unbalanced force to be negative, then we have to go slopes are decreasing from, that's the 17.5 to 35. And then where is the unbalanced force positive? That's when the velocity or the slopes of this are increasing. So slopes are increasing from 7.5 to 17.5. Use the velocity time graph given below to answer questions A through E. During what? Now, if you're working along with me and kind of working through this, and this, you're like, okay, that makes sense, that makes sense. Right off the bat here, you need to recognize that this now is a velocity versus time graph. And you should be tipped off, I think, by like the kind of jagged nature of this, like flat, straight, and so on. So this is velocity versus time. So the slope of this is equal to acceleration, right? So during what time intervals is the unbalanced force equal to 0? Saying that the unbalanced force is 0 is the same as saying the forces are balanced, right? So forces are balanced when the velocity is 0 or constant, and that's the places where this is flat. So unbalanced force from 0 to, what is this, 4 or something? I don't really care if you get that exactly right or the same as me from the graph. We're just doing our best. These numbers out. That looks like 14 maybe to 20, 30 to 36, and let's call that 45 to 50. Those are the places where the unbalanced force is 0 because the velocity is not changing. And it is equal to 0 for a little bit there, so the velocity is 0 or constant. During what time intervals is the unbalanced force not equal to 0? It's all the other places. So that's going to be 4 to 10. Oh, sorry, not 4 to 10, 4 to 14. Right, this, and then 20 to 30. And then 36 to 45. Those, because V is changing. If the velocity is changing, that means you got acceleration. Velocity is not going to change for free. That means there's got to be some unbalanced force. During what time intervals is the unbalanced force negative? How do you know? So the unbalanced force like we did on the last sheet, unbalanced force and acceleration have the same direction. So if the acceleration is the slope of this, when this has a negative slope, that must mean there's negative unbalanced force, or in that same negative direction. Just like here, when this thing was slowing down, the unbalanced force must have been like tapping against the direction of motion. It's going this way, but the unbalanced force is this way, which slows it down. All right, during what time intervals is unbalanced force negative? So that's from 4 to 14, 20 to 30, and that's it. That's where we have those negative slopes. How do we know? Because the slope of V versus t, which is A, is negative. How about the unbalanced force positive? Just only one interval here. That's the 36 to 45, because the slope of V versus T, which is A, is positive. During what interval is the unbalanced force the greatest? Just eyeballing it, it looks like that's definitely the steepest, right? We could actually try to put numbers on this, but this right here is, I think, clearly the steepest. Steepest, right there. So the unbalanced force is the greatest from 36 to 45 because this is the greatest acceleration, right? And it could have been the steepest in the negative direction. We don't care about which direction, it's just how much unbalanced force. That's going to go with whatever is the steepest part of this.